70% of the time, a software company that focuses on the end user will win a 5-year government contract if they're part of a cooperative purchase. Oh hey, it's your brother, Big Data. I mined through Big Brother's data and found the odds of winning a government contract. This is money-making intelligence to include a short list of buzzwords that you can employ in order to increase your odds of winning a government contract. This video is based off the scholarly blog article, which you can find a link in the video description below, giving you access to the code in Python and access to the dataset so you can replicate the findings yourself. And that's called science. I am highly confident at the end of this period of instruction, you'll be able to take what you've learned and apply it to increase your odds of winning a government contract. But first, AI news.
1990s, the Walmart Corporation applied a statistical machine learning model called market basket analysis and discovered that the purchase of diapers and beer were correlated on Friday nights. Since this discovery, major box stores throughout the entire industry have changed the store layout based on the big data finding. Market basket analysis is more accurate for predicting co-occurrences of item sets than the best large language models are, like ChatGPT or Llama. Additionally, when you walk into a grocery store, you can infer if the store is managed by a man or a woman based on the proximity of the diapers to the beer. And that's called science.
Let's mine through the data in Python.
Out there in the clouds, so high, it's a bunch of data on you and I. So inside, nobody knows what to do. There's a guy who's on your team. Takes through data and makes it clean. Feeds it to the machines for me and you. I'm talking. Big data. This here's big data. The data that you need. In this video you should like and get the data that you want. With data mine in mind, as we go on a data mine. Smash the bell. In this video, we showcase the predictive power of machine learning model called market basket analysis and how it's used. Additionally, the data was explored and tested with 4 other machine learning models. These models are principal component analysis, or PCA, K-means cluster analysis, random forest regressor, and XGBoost. With these predictive models, we answered the 2 following questions. Can a predictive model be created to forecast the total contract amount? And can market basket analysis be used to predict Washington state agencies' Internet of Things contract purchasing behavior? The following analysis comes from an open source dataset of IT contracts awarded to companies by organizations under the state of Washington containing the necessary variables about the state agencies requesting services and the private agencies awarded the contract. The dataset is sourced from data.gov. Data.gov is an open source government repository that hosts the datasets. The dataset contains almost 4,686 rows before any rows were removed and 69 columns. The dataset is limited to the metrics recorded. However, the dataset has multiple columns for exploration. Delimitations for this analysis: of the 69 columns, only 17 will factor into the exploratory analysis and 16 will factor into the regressive models. Additionally, only 15 features will factor into the final market basket analysis model. However, of the original 69, 3 additional features were engineered for exploration and testing. They are total time, 5-year representing the 5-year contracts, and 10-year representing 10-year contracts. The variables that were used for testing and market basket analysis were as follows: cooperative purchase, application, compute, data center, end user, delivery, network, IT management, output, platform, security, storage, other, and non-IT. In this part of the Python code, I am going to be importing all the libraries that I need. I definitely import way more than I need because I have an entire kata, a process, a flow, a movement that I go through and I mine through data. So I import these containing the necessary machine learning models. In this cell right here, I import the data set as a CSV file. Here I inspect the head. I have all the different columns and rows, and you can check out that data in the link in the video description. I always make a copy as good standard, and I check out the shape. 4,686 rows, 69 columns. I transpose it because I like to see the descriptive statistics as they're transposed this way, so it allows me to see all the columns all the way through, what variable types they are, and so I know I have some cleaning to do. And of course, right now I'm going into the cleaning portion where I'm dropping the null values. Not necessarily, I'm just getting a sum of the null values, and I'm going to drop them. Here I drop all duplicates, and I get another percentage of missing values, and then I drop all the missing values, and now the total shape is 4,500 86 rows. So yeah, pretty small in the sparsity. And so here I'm creating a start date with PD to date time and passing in the clean start date. Some of this I just used to create a better data frame for later on for possible exploration. Here I am replacing cooperative purchase with 0 and 1 to make it binary. It was a little bit more difficult for me to do with the get dummies function, so I had to just implement this code right here. Here I convert end date to regular date as well. Then I parse the contract dates by creating a new variable, total time. So total time is end year minus start year. And here I create 2 more variables, 10 year and 5 year, to get the total time, which is looping over with this lambda function. If one of these is going to be a 10 year, if it's 10 or 5, and it'll output it. And it was a really interesting finding too, because it was a pure 60-40 split. And here I just have them all, I have all the agencies separated out by agency number and name into a dictionary. So that way, if I wanted to do something better with predicting for agency number specifically, and I tried that and I really couldn't get anything out of it. So I only show to you the good findings that I do have that are valuable, actionable information. And so here we're going into the exploratory portion where I'm exploring each variable that's going to be on the market basket analysis. And that was, we see that application, compute, data center, delivery, end user, they're all basically binary. They're all basically binary and a little bit trinary, but they're basically binary. And we convert them down to binary before we go into market basket analysis, because that's one of the assumptions. And we can see that output is really not that big. And so we can see through this what is going to be the correlation. And we are looking here on start year. We can see that 2022 was probably, maybe 2020 was the biggest start year during the COVID pandemic. That would, I guess, make sense. I guess people were dumping money, possibly. I'm just speculating. Like the government was dumping money and doing a bunch of open purchase contracts or cooperative purchase contracts and trying to get more user-friendly platforms, because everybody was stuck inside a house and everybody was... Start month right here, July. July is the start month. End year. Most end years end in around 2025, because most contracts are 5-year contracts, and we're going to see that coming up. We can see it's around 2025, but some are going out to 2030. There's some contracts in the data set that are going out to 2050. And we can see the common end month is in June. So they'll start in July, but they'll end in June. But if we go into the cooperative purchase, we can see that it's a binary output again. So now if we look at cooperative purchase through the histogram, we can see that while the majority of the contracts are not cooperative purchases, that's true. Majority are not cooperative purchases. However, when we compare bivariate to at the same time, we compare cooperative purchase against total contract amount, we can see a big disparity, because like, look at this here. There's a big gap between the frequency of non versus due compared to the total contract amount of those that do get it, that are part of a cooperative purchase versus not. There's a huge ratio there, significantly different. So as we look at this bar plot indicating the length of total time, the contracts that are part of a cooperative purchase have more total time than the ones that don't. Okay, that's interesting. What about 5-year? Well, score, it looks like the 5 years have way more than the 5-year contracts. If it's part of a cooperative purchase, has the most frequency. And the reverse is true for 10-year contracts not being part of a cooperative purchase. Now let's look at the total contract amount over a start year. And what we can see is the most money was paid out in 96. But you can also see Moore's Law in action. Moore's Law in action. As time goes, computation gets cheaper and things get exponentially cheaper as computation gets exponentially bigger. So that's kind of interesting. So that correlates. And if we check out the most money, the total frequency of contract amount, the contracts that are getting paid the most are the ones that are ending in year 2050. Well, that makes sense. I guess they're getting more frequency of payments. And in all of these right here, I explored the top 30 agencies and I grouped them out. And I am going to, by contract amount, by 5-year, by 10-year, top hired contractors, to like which ones are hiring the most. And I am not going to go over that in this video. That will be covered in a separate video. We're going down to the machine learning portion of it. Let's go to the data frames themselves. So I played around. When I played around with this data frame where I was predicting total time with the 10-year and 5-year variables, it predicted it with 73% accuracy. However, that is akin to saying, oh, well, I'm able to predict if someone's mortgage is going to be a 20-year or a 15-year mortgage based on whether or not the input was a 15 or a 20-year mortgage. I can predict that 73% of the time. That's not really saying much. The biggest find of the machine learning models I found was market basket analysis. But you should also be wary of this. So there's a lot of unscientific charlatans out there that will engineer these sort of variables that if you're not really listening to what they're saying or looking at how the variables are made, you're going to think that you have something really good, but you don't. You're just kind of like reinventing the wheel and not, either way, that's a long-winded approach. Moving on to cleaning. So once again, dropping, and just in case, and then I convert all the infinities to 1. Go to this part, I do the is digit, so I convert agency number to in digit. And then I explore with the heat map, the correlation matrix. The correlation matrix is like the data mining gold pan. So if you have a gold pan and you can look at the data and the way it washes out and you see it through the black sands after you've already cleaned out all the rough stuff, and we've got to this part, we've got to the black sands, we can see like what correlates. We can see that when I created the two variables, 10-year and 5-year, are damn near perfect 60-40 split, and that's why it can predict total contract or total time pretty well. But then again, the intent was to predict total contract amount or try to find correlations of what people are buying. But when we look at here cooperative purchase, we can see that in cooperative purchase, these are the higher correlated words that people want. So these are your short list of buzzwords. We got compute, end user, and that's the big one. Storage, total time, in 5-year. All right, so your biggest buzzwords are actually going to be compute, end user, and storage. But moving on, so now you see how that works. So moving on, we're doing standard scalar, and we're going to be running. So I run principal component analysis, and in principal component analysis, we can see that all the variables they're even on variance. So there's not necessarily one variable that's going to be of a higher variance than the other variables, and we can see that here too. There's no distinct elbow method for the Kaiser criterion. So that's one of the things I do in my kata of data cleaning and exploration. The first two models I run is principal component, and then I run k-means cluster analysis. And in k-means cluster analysis, running with just one cluster, it's kind of like you're in a spaceship and you're zooming in towards a galaxy, and you can kind of like look at the galaxy of stars and how they go and cluster if you were to define it into 2 separate clusters, and then 3, and then 4. And then on 4 clusters here, I'm starting to notice here I'm starting to notice sort of more of a block shapes. And that's one of the visual signs that I go to, that I notice in my experience when it comes to market basket analysis and cluster analysis, is if you start to see these little blocked out shapes, you know that that's a good sign that this is going to be a very, very predictive model. There's something in here for market basket analysis. So now here I run random forest regressor. And I'm not going to run through them all because it's just going to take too much time computationally. But the moral of the story is the MSE is high. It's ridiculous. The R2 is worthless. You couldn't produce anything good. Same with the XG boost. Nothing good. And then I go down to MBA. So MBA, real quick, we're going to go over the assumptions, the almighty assumptions of market basket analysis. Has to be binary. The data has to be binary, meaning each item represents an absence or a representation of a transaction. It assumes a 0 or 1, where items are either bought 0 or 1 independence. If the item set is assumed to be independent of each other, this implies the purchase of one item does not influence the purchase of another. fixed basket size is another assumption. The number of items in the basket is assumed to be fixed, which it is. Static transactions. So MBA often assumes that transactions are static, meaning that the set of items in a transaction doesn't change over time. MBA doesn't consider the quantity of items bought, whether or not the item is present or not. It assumes that the co-occurrence of an item set is the transaction of the relevant information and customer homogeneity. MBA assumes that the degree of homogeneity among customers. This means that the behavior of one customer is representative of the behavior of other customers, and there is no time sensitivity. That means that it assumes that the order in which the items are purchased doesn't matter. In some cases, the temporal order might be important and other methods might. Moving on to it. We're dropping total time and contract amount. Why? They're redundant. There is always an instance of them because I created those variables. 2, converting everything to binary, looping through with the lambda function once again in the apply map function, ML extend, and then frequency patterns, and I call the a priori and association rules because that's what market basket analysis is based on. It's based on a priori algorithm with association rules. Then I create the frequency item data set, pass in the binary. I use a minimum support 01, and that was the one I found as the best. And same with the metrics. I played around with them. This seems to be the best one as of now. And it generated this output of all these different co-occurrences of the government with their purchasing behavior. Then I pruned them down to where the confidence is greater than 50%. So that's going to be a big factor, and we found some good ones. So let's talk about it. What is consequence? A consequent or item or features that are found together in the data set after the transaction, i.e. the outcome. The antecedent support, 1% of the transactions that contain the antecedent items. The consequent support, the percentage of transactions that contain the consequent items. Support, the percentage of transactions that contain both the antecedent and the consequent. Confidence, the likelihood that the rule is true, the conditional probability of the consequent given the antecedent. Lift, the ratio of observed support to the expected support if the antecedent is and the consequent were independent. Lift of greater than 1 applies the presence that the antecedent increases the likelihood of the consequent. Leverage is the difference between the observed frequency of the antecedent and the constant appearing together and the frequency that would be expected if they were independent. Conviction measures how much the consequent and dependent are the antecedent. In Young's metric is a statistical measure that's used to evaluate the strength of association rules for data mining. Only 7 rules exist after pruning, and they are great. Look at this, N year, 5 year. So it doesn't matter like one comes before the other because that's part of the assumptions. And we see the antecedent support is almost 20%. That's really good. Consequent support, 30%. Confidence, 70%. But mostly I'm looking at confidence. I'm looking at Zhang's metric. And right here, confidence at 70%, Zhang metrics at 75%. If you're an end user with a 5-year contract and you're part of a cooperative purchase, 70 to 75% chance you will get a government contract. That is the number 1 ranking rule. And of course, network and end user are also great buzzwords to throw around. So we see that network is also associated very loosely, very, very so minimally with that. However, cooperative purchase 5-year, 57% right off the bat. Cooperative purchase with end user, 61%.
What's a cooperative purchase? And if you want to learn what a cooperative purchase is, then watch this video up here. And that's why you should also subscribe and smash the bell. Thank you for watching this video all the way to the end. Please leave all your questions in the comments below and I'll be sure to get back to you. Remember that sharing is caring. I'm Data Mining Mike, and thank you for watching.
Hey, Dater! This here's Big Dater. Get the data that you need. In this video you should like and get the data that you want. With Data Mining Mike and subscribe as we go on a Data Man. Smash the bell.